Good afternoon, everyone. This is Sai Rakesh, Business Development Executive at ChrisWorks Technology Innovations. So today, I'm very much excited to speak about one of our successful delivery projects, which built with full stack and AI and IoT integration. So the topic is from 20 to 400 plus installations, scaling a production platform with full stack and AI. Let's have a quick brief about who we are. So we are ChrisWorks Technology Innovations, an IoT and full stack engineering company. We develop full stack applications, AI solutions, IoT applications, edge and cloud platforms, and scalable IoT products. We help businesses and industries transform their ideas into production ready solutions. Some of our deliveries and capabilities are we have almost developed 50 plus products across full stack, AI, and end-to-end IoT product development and with mobile applications. We have also collaborated with Indian Army for IoT implementations, and we have worked on the projects for the government of India. Also, we have our client footsteps over Australia, USA, Netherlands, Canada, and other countries in the globe. We have our own product, which is SiteTrack RTLS, an IoT-based real-time location intelligence platform. So let's jump into the topic from 20 to 400 installations. Inside a production scale platform, which is built with full stacks AI and then IoT implementation. What we will cover is today is a system architecture of our platform, IoT edge device computing, OTA flow, as well as order lifecycle, and few of the implementation that we did is caching, AI, and multilingual and analytics. Also, finally, we will be seeing the engineering lessons that we learned from this product development, as well as what business impact that we have created for the client. So what exactly happens when the customer click place order? So imagine you are walking into a chain of restaurants or a retail store and you are having a digitalized menu in your mobile applications. And do you know what exactly happens when you click place order in our platform? Like a single click which triggers a distributed system in our platform, which involves cloud servers, virtual machines, message queues, databases, edge devices, AI services, and analytical pipelines, and controlling the thermal printers and deployment infrastructure. So most people will see only the customer interface, but the engineering have to build everything behind it. So let's see system architecture of our platform. The overall system architecture is having three different users where three users have its own responsibilities. The first is customer platform, which the end user of the platform, which is the customer using this particular platform, which is built with Next.js, TypeScript, Redux Toolkit, and TanStack queries. Then here comes admin portal, where this admin portal will be used by the restaurant managers or retail store managers, where they can update their menus or manage their menus and monitoring the orders, controlling the or monitoring the printers, as well as generating the report and monitoring the day-to-day operations. Here comes the superstar of the whole platform, which is Super Admin Portal, where he can onboard new clients, manage the hundreds of edge devices at each restaurant or the shops, and then OTA deployments and monitoring the overall ecosystem of the platform. Also, we have a dedicated cloud backend, which is a communicating line between the front-end platform and the edge devices at each shops. Yeah. So here comes what exactly happening at the back end, and this is order processing flow. So when the customer clicks a place order, so the query will be sending to the single server, which is a Node.js backend. So instead of sending it to the single server, we have a load balancer, where the purpose of the load balancer is to send the incoming traffic to across multiple virtual machines to reduce the overloading as well as high availability. And then once these queries reaches the Firebase database, when then it retrieves the particular shop's configuration and it publishes to the RabbitMQ, where this RabbitMQ acts as a communication bridge between the backend server as well as the edge devices at each shops, where the communication protocol will be AMQPS, where it is what the secure RabbitMQ communication. Once the queries are reached to the edge device, and then it will automatically process the automating billing processing system, where there is no need of a person to stand in a queue, or there is no need of a person to sit in front of the desktop and generating the bills for each and every orders. So here comes Edge Gateway. Each shops or retail stores or restaurants will have their dedicated edge devices, and which acts as an edge gateway, where it communicates with the printers and it processes the orders locally, and then it manages the local queue. And also it will monitor the overall device health, and it helps to OTA software updates, and then finally offline order storage. So, as our platform continued growing, we have faced a major problem, which is we have received almost 12 million database reads per day, which affects in rising infrastructure cost at this scale. So, instead of optimizing each and every query individually at the backend, we have implemented a caching aggregation layer. The frequently fetching informations like shop configuration, product catalog, or printer mappings or visitor data have been cached instead of fetching them from the DB reads. The results were substantial. We have seen almost 80% reduction in the DB reads, which helps both for us as well as the client's businesses. And here comes AI menu management and multi-language support. The another major problem was this: each and every shop managers or restaurant owners will be updating their menus frequently. So implementing or entering hundreds of products or catalogs into a system manually is time taking as well as error prone. So we have implemented artificial intelligence system where it allows managers to upload their menu document. Then the system will automatically extract the categories, items, and the prices. Then it structures the full menu hierarchy. This helps us in the faster onboarding as well as fewer manual error. Multi-language support. Where we have implemented a Google Translate API at the backend, where it helps the managers to translate his particular menu to multiple languages instantly, as well as we have a localized language file in the front end, where each and every users can view the menus at their preferred languages. Here comes Google User Analytics. So beyond developing a full-scale customer platform, we also wanted to understand how our end customers are interacting with our platform. So we have streamed each and every analytical event to the Google BigQuery, which helps us in understanding the user behavior, ordering trends, and generating the heat maps. Also, we have understood the customer journey, and the major important thing was anomaly detection that we have done, as well as the future adoption. And here comes the important and major part of our whole platform, which is OTA update pipeline. So all these edge devices will be placed at each restaurant or the shops, retail shops, where it is managing the hundreds of devices remotely will be critical. So we have developed a structured OTA update pipeline, which allows the super admin to upload a software package to the backend. Once it reaches the backend, it automatically validates the particular package, and then it publishes to the RabbitMQ, where the RabbitMQ, as I told, that is a communication bridge between the backend as well as the edge devices at each shops and the restaurants, where it will update the software in the queue. Once these edge devices have the notification of the new software updates, it automatically started downloading the package and it starts the installation. Once before the installation, it also do a verification process. Once the verification is successful, then the edge device will automatically update its software or updated software into a newer version, or if anything is failed, then it will roll back to the previous stable version by notifying the super admin, which particular ID at which restaurants or the shops. So this structured OTA update pipeline helps us in like monitoring the hundreds of edge devices or updating the hundreds of edge devices remotely. Finally, here comes engineering lessons and then business impact that we created. A major key lessons that we have, one of the major key lessons that we have learned was distributed systems like our platform always need an asynchronous communication. And edge devices improves reliability when the internet connectivity is unstable. Also, message queues simplifying the scaling process, and caching can cut the cost as much as code can does. And AI will be very much helpful when it removes the repetitive work like a manually entering process or the repetition. And also OTA is critical at IoT while managing the hundreds of devices. These are all the key lessons that we have learned when we were developing this particular product. Also, the business impact that we have created as a as a technology partner, like we have helped the client to grow from 20 to 400 plus installations in a span of 1 to 2 years time, as well as we have reduced 80% database reads cost, as well as zero downtime deployments in the OTA updation, and 100% remote device management. And I would like to conclude this session by saying the squad, which is good engineering doesn't just solve today's problem, it builds the foundations for the tomorrow's growth. Thank you. Questions, like if you have guys any questions, you can put in the comment. Would like to answer it. So Mr. Siddhant is asking, what is the biggest challenge when scaling from 20 to 400 installations? Uh, yeah, Mr. Siddhant, like as you told, we have faced a few challenges like database reads, as well as we have implemented this smart caching layer, and then the virtual machines. The biggest challenge is maintaining the reliability. Basically, as our number of customers grows, like we have to maintain this smoothly without delays or downtime. Thank you, Mr. Siddhant. So Angel Thomas ma'am is asking, why is caching important? So the caching stores frequently used data. So we the system doesn't have to um, uh, read the data from the backend of frequently fetched data. So we have implemented a caching layer. This improves the speed and reduces the cloud cost. So that's why we have implemented the caching, and it is important for such platforms. Thank you. Mr. Suraj is asking, what role does AI play in your platform? Yeah, as I told that AI, we have implemented for like reducing the repetitive work in our platform. As I told, updating the product catalog or the menus every time, or hundreds of products is both time taking as well as to error prone. So we have implemented this AI to extract the menus and categories from the document, as well as we have implemented for the multi-language support. Thank you. And Mr. Maheshwaran is asking, why did you choose cloud-based architecture? Yeah, the cloud architectures actually allows us to scale easily, as well as whenever more shops or new onboarding clients have been added, like we can increase the resources without rebuilding the entire system. So that is why we have choose the cloud-based architecture. Mr. James is asking, what is the benefit of using RabbitMQ? Thank you, Mr. James. So, RabbitMQ actually acts like a delivery manager. Like it actually makes sure the messages and the order reach where the correct destination without getting lost or even in the high traffic. So that's why we have used RabbitMQ, and this is beneficial for us. Mr. Jagan is asking, can you explain why edge devices important? So, why edge devices is important? Like edge devices keep the restaurant actually running even if the internet goes down, and then orders like can be still processed in the locally, and then